Okay, we just spent some time looking at how performance trending, either through UMCS front ends or with portable data loggers, represents one way to more or less talk to our buildings to find out what their systems are doing. Functional tests represent another way to do this. So in this section, we want to expose folks to the concept of the functional performance test, how it's written and conducted, so that we can focus on using tools and doing some of this in the field during the practicum. So a few distinctions. With trending, we're looking at facility system performance over time. With functional testing, we want to see how our systems respond to some change in operating conditions. We may need to use a number of tools to do this, including portable data loggers, but functional testing is more about observing or measuring these responses. There's two ways to do functional testing: natural or forced. Natural responses occur when watching the system react to change based on how it's been programmed or configured. So something like observing a normal startup sequence, or watching how economizer dampers modulate throughout the day. Forced responses are more common to RCX functional testing, since we're manipulating the system to have it show us what it does under some specific set of conditions. Examples of this include testing of system schedules, forcing a sequence through its reset range, sensor calibration checks, and equipment staging. But there's really an endless combination of system conditions that could be tested against. The skills and procedures for RCX functional testing are nearly identical to those required for new building commissioning and acceptance testing. However, the intent is different. In construction projects, we test to show that contractual requirements have been met. With RCX, it's more open-ended than that, and regardless of how a system may have been designed or commissioned, we want to understand what it's doing and how it can do things better. So CX, at least the testing portion, is really a project QA process, and RCX is reversed, where we start with a finished product and run through how it's working the way it is, and querying the building to find out how things can be optimized. The way that we read a response can vary by application. Reference Searle's tool lending library for some examples, but it's the way that we force a response that needs extra consideration. There's a number of ways we can override, bypass, or trick systems to do what we want for testing purposes, but there are right and wrong ways to go about this. A few rules of thumb: whenever possible, a change upstream in the control system is generally better. So if you want to, say, shut down a supply fan VFD, you could do this at the local disconnect, but to avoid unnecessary front-end alarms, what's called control loop windup, and possible damage to moving drive components when you reconnect the circuit, try to make this change at the front-end interface or local display panels. Use your knowledge of HVAC fundamentals to think about what should and could happen when you intervene in system operations. If you're testing VAV airside systems for something like zone scheduling or duct static pressure set point reset opportunities, make sure discharge pressure sensors are installed and working. If you're doing a pump test, consider what deadhead pressure will be and how your pump seals may hold up to that. And if you're opening up access panels in an AHU while it's running, think about what filters and coils you may now be circumventing and whether that's okay given your space function. But the most important rule of thumb is coordination. If you want to affect some change in one of your systems, who needs to be aware of what you're doing, or approve it beforehand, or be contacted if something goes wrong? Know these roles, responsibilities, and procedures ahead of time, whether you're performing the test yourself or managing someone who is. And just like the monitoring plan helped us organize our trending needs, functional test sheets can help us plan and perform a tight functional test. For a great resource on all things functional testing, go to ftguide.org, where you'll find a guide to this kind of field testing, additional information on control systems, and an expansive directory of downloadable functional test templates compiled from a number of different industry sources. There are pre-functional checks focused on preparation tasks, functional test procedures listing the test steps needed, combined forms that do both, and guidance documents to help walk through the strategies used. Perhaps the best document here to focus on is this general guidance, as it contains a blank test sheet that can be tailored to any system or test needed. So let's go through what the typical sections of these functional tests look like. First, you'd list why you're doing the test, so what information you need and what problem or opportunity you're trying to quantify or qualify. This would also include acceptance criteria, or at what point you can say the test is complete and you've gotten what you need. Next, list the equipment required, so any instrumentation or tools that need to be ready to conduct the test. Also, it's critical to think through and document what preparation, precautions, and prerequisites exist prior to the test being ran. And don't forget to document all the coordination that needs to happen. Once you've done all that, the meat of this form will be the test procedures, where all steps are detailed. But one of the most important things on this form is the reminder of how to go about returning the system to normal once it's finished and what follow-up tasks are necessary. As we said, functional tests can vary widely. You may want to look at how economizers and related sensors perform during warm-up, how a thermal flywheel cycle may help reduce plant equipment short cycling by leveraging the thermal mass contained in distribution networks between cycles, or ascertain waterside flows to determine if you have a good candidate to optimize pump operation with something like an impeller trim. We're going to walk through this last example in an exercise where we build the functional test needed, then show what it looks like to perform it. So if you're part of the RCX Practicum, please use the link in the comment section to continue on to our functional test exercise, and thanks for watching.